When we think about cybersecurity, our minds usually jump to hackers in dark rooms or endless streams of code, right? But what if I told you the strongest defense a network has isn't software, but its actual blueprint, the way it's designed from the ground up? Let's dig into why that is.
So here's our game plan. We're going to imagine our network is a high-tech museum. We'll look at who has the keys, the clients and servers. We'll map out the different floor plans, build a super secure wing for the good stuff, peek at the architect's master plan, and finally, talk about the one thing that can bring it all crashing down.
Okay, let me ask you a question. You're in charge of a museum. You've got a priceless Van Gogh on the wall. How do you protect it? You're probably thinking guards, cameras, laser grids, all that cool stuff. And yeah, you need that, but you're missing the most important piece of the puzzle.
See, real security, it starts with the blueprint, the layout of the rooms, where the hallways go, how many doors there are. Before you even think about hiring a single guard, the architecture of the building itself is your very first and, honestly, your most important line of defense. And for a computer network, it's exactly the same thing.
So before we can even start drawing our blueprint, we have to decide on the roles. Who's in charge here? In the world of networks, this really boils down to two main models that decide who holds the keys and who has to ask permission to get in.
So on one hand, you have the client-server model. Think of this like a central bank vault, the server, that holds all the art. When you watch a movie on Netflix, your laptop is the client, and it's asking a massive Netflix server for that file. It's all very controlled and easy to scale up. Then you've got the peer-to-peer model, which is a totally different ballgame. Here, every room manages its own art and shares it directly with the other rooms. Remember those old file-sharing apps? You were downloading little bits of a song from dozens of other people, or peers. No central vault, which can be faster, but way riskier if one of those peers is compromised.
Okay, so we've got the roles figured out. Now it's time to choose the actual floor plan for our digital museum. In networking lingo, these are called topologies. And believe me, each one has huge security pros and cons.
First up is the most straightforward design you can imagine, the bus topology. Just picture your entire museum as one single long hallway. That's the backbone. And every single room just connects right into it. Simple.
And you can see the appeal, right? It's incredibly simple to set up. It's cheap. You don't need a ton of cable. For a small, maybe temporary network, this layout is super fast and easy. But, and this is a big but, that simplicity is its fatal flaw. Since every single thing relies on that one hallway, what happens if a thief cuts the power to it? The entire museum goes dark. A single point of failure takes down the whole network. Game over. All right, next we've got the ring topology. Now picture all the rooms connected in a big circle. Data flows in one direction like a polite tour group, passing from one room to the next, to the next, to the next.
The big win here is that it's orderly. With all the traffic flowing in one direction, you don't get data packets crashing into each other. That means you get really consistent, predictable performance.
But here's the catch. What happens if one room needs to go on lockdown? Well, it breaks the entire circuit. The Tor stops for everyone. Taking just one device offline can halt the flow of information for the whole network. Not great.
Now for the one you almost certainly use every single day, the star topology. In this museum, there's a central security office, a hub or switch, and every single room has a direct private line to it. This is exactly how your home Wi-Fi works. Your phone, your laptop, your TV, they're all talking directly to that one central router.
And the benefits are massive. If one room has an issue, you can just shut it down without affecting anyone else. Want to add a new TV? Just run a new connection to the central office. It's so easy to manage and grow. But, and you've probably already spotted it, this design has one giant glowing vulnerability. That central security office. It becomes the ultimate single point of failure. If an attacker takes out that hub, the entire museum network goes offline. Every single room is cut off.
So, we've seen layouts with some pretty major weak spots. But for our truly priceless treasures, we need a high security wing. We need the most resilient, most bulletproof design we can possibly make.
And that brings us to the gold standard of network design, the mesh topology. This is the blueprint you pull out when failure is absolutely positively not an option.
So why is it so tough? Well, in a full mesh network, every single device is connected directly to every other device. Think of it like a web of secret passageways. If one hallway gets blocked, who cares? Data just instantly finds one of the dozens of other routes to get where it's going. It completely eliminates the single point of failure, making it incredibly reliable.
So we have all these floor plans, these topologies, but how does a cybersecurity architect actually take these ideas and build a secure system that works in the real world? Well, it's a really disciplined three-phase process.
First, the architect creates policies and standards. This isn't just boring paperwork. It's asking the big questions, like what data is most valuable and who really needs to access it. Second is implementation. This is where you build security in from the very beginning, not try to bolt it on later. You're putting the right locks on the doors as you build them. And third, you monitor. You never stop watching. It's like having guards on patrol 24/7, always looking for anything that seems out of place.
Now, after all of this, all these resilient blueprints, these careful plans, you would think our museum is an impenetrable fortress. But there's one more factor, one that we haven't talked about yet, and it's responsible for a truly staggering number of security failures. 74%.
That's right. Almost 3/4 of all data breaches involve a person, the human element. At the end of the day, the biggest threat isn't some brilliant flaw in the blueprint. It's a person inside the museum, a guard, an employee, who makes a mistake.
And that really brings us to the final, most important point. You can design the most secure building on Earth, a perfect mesh network with absolutely no single point of failure. But none of that matters if someone leaves a door unlocked. So the question I want to leave you with is this. In the digital museum where you work and live every day, what's your role in making sure the doors stay locked?